Hello students, let us start remaining nucleophilic substitution reactions of alkyl halides. Next, nucleophilic substitution reaction of alkyl halide with potassium cyanide, and the formula is KCN. With potassium cyanide, alkyl halide RX, haloalkane, reacts with alcoholic potassium cyanide. Replacement of halogen atom of alkyl halide by cyanide group nucleophile Cn- takes place, and the product is RCN plus Kx. Product is alkyl cyanide. Cyanide product is also known as nitrite, and thus the product is alkyl cyanide. That is, nitrile is obtained. For example, methyl iodide, CH3I. Methyl iodide, iodomethane, is heated with alcoholic potassium cyanide. As in the general reaction, substitution of halogen by cyanide group takes place, and thus removal of iodine atom by cyanide group takes place, and the product is CH3 CH3Cn with the elimination of potassium iodide, Ki. Product is methyl cyanide. It is also known as ethane nitride, as methyl cyanide contains 2 carbon atoms. It is ethane nitride. Ethane nitride. And there is one more name for methyl cyanide as acetonitride. Acetonitride. And thus methyl cyanide is ethane nitrile is also known as acetonitride. Thus alkyl halide, when heated with alcoholic potassium cyanide, gives the product cyanide, alkyl cyanide. Next, with silver cyanide, reaction of haloalkane with silver cyanide, AgCN. Consider general reaction. Alkyl halide reacts or heated with silver cyanide, AgCN, which is also alcoholic. The reaction mixture is heated, and the removal of halogen by isocyanide group takes place, and the product is RNC. Alkyl isocyanide is obtained with elimination of silver halide, AgX. Product is alkyl isocyanide. Consider, for example, methyl bromide. Methyl bromide is heated with silver cyanide. Substitution of bromine by isocyanide group takes place. Replacement, removal of bromine atom from methyl bromide by isocyanide group takes place, and the product is methyl isocyanide with AgBr, silver bromide. Thus, when alkyl halide is heated with silver cyanide, product is isocyanide, and when alkyl halide is heated with potassium cyanide, product is cyanide. Why? The products are different in both the cases. To know the different products, let us consider the basic point which is related for these reactions. And for that, consider nucleophile cyanide ion. Cyanide ion. Cyanide ion adds Cn minus. This cyanide ion has two attacking sites. It has two attacking sites. Two attacking sites. How? See the structure of cyanide nucleophile as C triple bond N, carbon with pair of electrons, it possesses negative charge, and nitrogen with pair of electrons. Cyanide. If one of the triple bond is shifted to nitrogen, this one of the triple bond is shifted to nitrogen, then the structure obtained is C double bond N. Carbon has pair of electrons. Already nitrogen has one pair of electrons. And this shifted electron pair goes to nitrogen. And thus, negative charge is present on nitrogen. If you look at these two structures of cyanide ion, then in the first case, carbon possesses negative charge and thus the attack of nucleophile cyanide ion takes place through carbon. Attack through carbon. While in the second case, as nitrogen positive charge, attacking site is nitrogen and thus the cyanide ion attacks through nitrogen. Attack through nitrogen. And thus cyanide ion has two attacking sites, carbon and nitrogen. As a nucleophile possesses more than one attacking site, then that nucleophile is known as ambident nucleophile. Ambident nucleophile. And thus cyanide ion is ambident nucleophile. It has two attacking sites. One is carbon and another is nitrogen. Then what happens in these two reactions as the products are different? Consider for example potassium cyanide. Consider first case potassium cyanide KCN. In between potassium and cyanide there is ionic bond. Ionic bond is present between carbon and between potassium and carbon of cyanide. See, this is carbon, C triple bond N. When this potassium cyanide is dissolved in solution, if it is added in solution, it ionizes as K plus and Cn minus. Negative charge is present on carbon. See, KCN is an ionic compound. Ionic compound. It is ionic compound, and thus when it is added in solution, it ionizes as K plus and Cn minus. This cyanide ion formed has two attacking sites. It can attack through carbon or nitrogen. Here, this cyanide carbon forms a stable, strong bond with carbon of alkyl halide. See how. Consider, for example, CH3, CH2, Br is treated with potassium cyanide. This carbon, cyanide carbon, forms a bond with this carbon, CH3, CH2, Cn. Cyanide carbon forms a bond with carbon of alkyl group, and the bond formed by cyanide carbon with this carbon-carbon bond is a strong and stable bond than bond formed by carbon with nitrogen. As carbon-carbon bond is strong and stable bond, alkyl halide with potassium cyanide forms alkyl cyanide, while in case of silver cyanide, AgCN is a covalent compound. It is a covalent compound. There is a covalent bond between Ag and carbon of cyanide. There is a covalent bond between silver and carbon. What is a covalent bond? Covalent bond is that bond which is formed by sharing of an electron pair. Thus, carbon of this cyanide group is not free to attack on the alkyl halide. This carbon, its electron is shared with electron of silver, and thus this carbon is not free to attack, while nitrogen of this cyanide group, it is free to attack. See carefully. Silver cyanide possesses cyanide group. Cyanide has two attacking sites, carbon as well as nitrogen. In case of silver cyanide, as it is a covalent compound, this carbon forms a covalent bond with silver, and thus carbon is not free, while nitrogen is free to attack. It possesses lone pair of electrons, and it can easily attack carbon of alkyl group, and thus when silver cyanide attack on alkyl halide molecule, the attack takes place through nitrogen, and thus the product alkyl isocyanide is formed, in which attack takes place through nitrogen. And thus, when alkyl halide is treated with potassium cyanide, product is alkyl cyanide, while if it is treated with silver cyanide, product is not cyanide. Product is alkyl isocyanide. And how it is explained? It is explained with the help of nature of these two compounds. Potassium cyanide is ionic compound while silver cyanide is covalent compound. As potassium cyanide is ionic compound, its carbon can form strong stable bond with carbon of alkyl halide and the cyanide formation takes place. While cyanide, in this case, cyanide of nitrogen is more electronegative. As nitrogen is more electronegative than carbon, bond formed by nitrogen is weak bond and it is unstable, and hence the preferred product is cyanide in case of potassium cyanide, while the preferred product is isocyanide in case of silver cyanide. These are the two important reactions. You have to remember most important point as when any alkyl halide is treated with potassium cyanide, product is alkyl cyanide. While if alkyl halide is treated with silver cyanide, product is alkyl isocyanide. See the difference between the two products and why these different products are obtained on the treatment of potassium cyanide and silver cyanide. As cyanide is ambident nucleophile. It can attack through carbon as well as nitrogen, and it depends upon the nature of compounds potassium cyanide and silver cyanide. Same with another reaction, that is potassium nitrite and silver nitrite. Same type of reaction. This is the last nucleophilic substitution reaction of alkyl halides. Seventh reaction of alkyl halides with potassium nitrite. Potassium nitrite. Potassium nitrite, potassium K and nitrite NO2. We can write this molecule in different style as K O N double bond O. Potassium nitrite. K O single bond N double bond O. Here ONO is a nucleophile. O minus attacks on the carbon of alkyl halide. While ONO group, this nucleophile is ambident nucleophile like cyanide ion. So let us see how reaction takes place. Consider for example alkyl halide RX, haloalkane, is treated with potassium nitrite K, single bond O, single bond N, double bond O. When haloalkane is treated with potassium nitrite, attack of potassium nitrite through oxygen on alkyl halide carbon takes place and the product is R, single bond O, single bond N, double bond O. Thus attack through oxygen. And thus the product is alkyl nitrite. alkyl nitrite. ONO has two attacking sites, oxygen as well as nitrogen. Here, when potassium nitrite is treated with alkyl halide, attack takes place through oxygen, and thus this oxygen can form a bond with carbon of alkyl group. Oxygen forms a new bond with carbon of alkyl group, and thus the product alkyl nitrite is obtained. Consider proper example: ethyl bromide CH3 CH2 Br. Ethyl bromide, also known as bromoethane, is treated with potassium nitrite K single bond O single bond N double bond O. Attack of potassium nitrite through oxygen on this carbon takes place. Attack through nitrogen on this carbon, and thus removal of substitution of bromine atom takes place, and thus the product is CH3 CH2 CH3 CH2 O. Oxygen attacks on this carbon, and thus this is oxygen. O, remaining molecule as it is, single bond N double bond O, and thus the product is alkyl nitrite. Alkyl nitrite is obtained. Next, reaction with silver nitrite. Silver nitrite. Silver nitrite is AgNO2. When silver nitrite is treated with alkyl halide AgO single bond N double bond O. When silver nitrite is treated with alkyl halide, then attack takes place through nitrogen. Nitrogen possesses lone pair of electrons, and thus attack through nitrogen takes place. Attack through nitrogen, and thus the product is RNO2. Product is RNO2. RNO2. This Ag combines with removed halide, and the side product is silver halide. When silver nitrite is treated with alkyl halide, product is nitroalkane. Nitroalkane is obtained. Check the difference between the two reactions. When alkyl halide is treated with potassium nitrite, product is alkyl nitrite, while with silver nitrite, product is nitroalkane. Here alkyl nitrite, and in this case nitroalkane. Why this is so? Because NO2 group has two attacking sites. It is ambident nucleophile. It can attack through oxygen or it can attack through nitrogen. And attack through oxygen or nitrogen depends upon nature of the molecule. What type of molecule is treated with alkyl halide, and thus the products are different. Here alkyl nitrite is obtained, product is nitroalkane. This is the last nucleophilic substitution reaction of alkyl halides. Let us revise all these nucleophilic substitution reactions. alkyl halide present on the reactant side. First nucleophilic substitution reaction of alkyl halides is action of strong alkali potassium hydroxide or sodium hydroxide, which is in the aqueous medium, aqueous KOH or aqueous NaOH. What is the product? Here nucleophile OH minus attack on the carbon of alkyl halide and the product is alcohol. Formation of alcohol from alkyl halide. Second nucleophilic substitution reaction of alkyl halide with sodium alkoxide NaOR or NaOR. Here alkyl halide as R, NaOR as R dash, different alkyl group. When alkyl halide is heated with sodium alkoxide, formation of ether takes place and the product is ROR. ROR and ether is formed. This reaction is given by Williamson's and thus the reaction is known as Williamson synthesis. Next, when alkyl halide is treated with silver salt of acid or COOAG. Third nucleophilic substitution reaction of alkyl halide. When silver salt of carboxylic acid is heated with alkyl halide, attack of this RCOO minus on alkyl halide carbon takes place and the product is RCOOR and thus ester formation takes place. Ester. Next nucleophilic substitution reaction of haloalkanes with ammonia. How to write separate form of ammonia? As NH2 and H. Nucleophile NH2 attack on carbon of alkyl halide and the product is RNH2. RNH2. Product obtained is primary amine. Formation of primary amine from alkyl halide by the action of ammonia. Next nucleophilic substitution reaction of alkyl halides with potassium cyanide. As potassium cyanide is ionic compound with alkyl halide, it forms alkyl cyanide. Cyanide formation. When alkyl halide is treated with silver cyanide, as silver cyanide is a covalent compound, carbon is not free. It forms a covalent bond with silver. As nitrogen is free, it attacks on the carbon of the alkyl halide and the product is alkyl isocyanide. Alkyl isocyanide. And lastly, when alkyl halide is treated with potassium nitrite, KNO2, KON double bond O. When it is treated with potassium nitrite, product is alkyl nitrite, RON double bond O. Attack through oxygen, and when it is treated with silver nitrite, when alkyl halide is treated with silver nitrite, attack takes place through nitrogen and the product is nitroalkane. Rn, carbon nitrogen bond, here carbon oxygen bond, and thus these are few nucleophilic substitution reactions of haloalkanes. We have to take revision by taking different molecules of alkyl halides, or take alkyl halide molecule, you will get alcohol, and try to recall these conditions. What conditions are used to get the specific points for a specific product. So these are important few nucleophilic substitution reactions. Let us study next type of reactions of alkyl halides, and that is elimination reaction, which is very important. Second type of reactions of alkyl halides, elimination reaction. Elimination reaction of alkyl halide. This elimination reaction of alkyl halide is also known as beta elimination or beta elimination reaction. Elimination or beta elimination, or also known as 1,2 elimination. 1,2 elimination reaction. Elimination reaction of alkyl halide. What is elimination? Elimination means removal. Removal of what? Before that, consider one basic point. When halogen is present on a carbon atom, then that carbon is known as alpha carbon. Carbon bearing halogen is known as alpha carbon, and the carbon which is next to alpha carbon which is next to alpha carbon is known as beta carbon. Hydrogen atoms present on beta carbon are beta hydrogen atoms. Carbon bearing halogen is alpha carbon. Carbon atom which is adjacent to alpha carbon atom is beta carbon, and the hydrogen atoms present on beta carbon are beta hydrogen atoms. Elimination reaction of alkyl halide is dehydrohalogenation reaction. Dehydrohalogenation. If you break this word, you will get the meaning of this term. D means removal of hydro means hydrogen and halogen. Removal of hydrogen and halogen from the adjacent carbon atoms of alkyl halides is known as dehydrohalogenation. But how this dehydrohalogenation of alkyl halide takes place? So look at this molecule. Hydrogen of beta carbon and halogen of alpha carbon takes part in the elimination reaction, and thus hydrogen atom from beta carbon and halogen atom from alpha carbon undergo elimination, and thus alkyl halide undergo elimination from beta hydrogen and alpha carbon, and this is dehydrohalogenation reaction. How this dehydrohalogenation takes place? Important condition of dehydrohalogenation. When alkyl halide is heated, with alcoholic potassium hydroxide, alcoholic potassium hydroxide, dehydrohalogenation takes place. Alcoholic medium is required. This is very important. Potassium hydroxide in alcoholic medium is used for the dehydrohalogenation reaction. How this reaction takes place? Potassium hydroxide is a strong base and it possesses a strong nucleophile OH minus, and thus base is electron rich as it possesses strong nucleophile. When this base attack on any alkyl halide molecule, this is alpha carbon with halogen and this is beta carbon with hydrogen. Stronger base which acts as a nucleophile, which supplies nucleophile to the reaction, this base abstracts proton from alkyl halide. This base abstracts this proton. As this base takes this proton, carbon-hydrogen bond breaking takes place and thus a new bond is formed between carbon-carbon. Base abstracts this proton and forms BH+. Electron pair is used to take this proton and thus at the same time halogen leaves as X minus. And thus when any alkyl halide is heated with alcoholic potassium hydroxide, elimination takes place. Dehydrohalogenation takes place and the product is alkene. Alkene formation is possible. See, what is dehydrohalogenation? Removal of beta hydrogen and halogen from alpha carbon. Removal of hydrogen and halogen from the adjacent carbon atoms is known as elimination reaction of alkyl halide, and